This screencast is a demonstration of some code, Lean Loris, as I call it, which is for automated forward reasoning and mixed reasoning in the Lean theorem prover. It can be used in semi-automated way as well. The reason why this is being run in the command line is because it needs compiled Lean code. In the future, one would be able to do it maybe by separate compilation of modules and so on, but for now it cannot be run in the interpreter. So this is for convenience of people. They don't have to download, build and run things. So I have just demonstrated. As you see, when you have downloaded and built this Lean Loris using Lake build, you will be in a situation where you can run the command and it tells you it can do 3 things in the command line. There are many other simpler things that can be done in the interpreter, and that's always nicer, so they are not duplicated here. And what I'll do now is look at the first of these and we'll time it, which is a problem from the Czech Slovak Olympiad. I'll state this as we go along. It's stated in the code. If you run it like this with the first Olympiad, this is a purely forward reasoning problem. That is to say, we start with premises, and while we will log what happens in terms of progress and goals, it is at no stage being used. Okay, so as you run it, it will tell you the problem. You can read the problem, and it went through the first step as well. So it's M is a set with a product, and there are a couple of axioms. It's somewhat similar to the standard algebra problem that if your group has every element of order 2, then the elements commute, and indeed the conclusion here is commutation. So we are going to follow this, and to follow this we will define these exclamations are to emphasize as a statement, not a proof. We define the statements of a bunch of lemmas which will be the steps in a proof of this result. Now what you'll see is that as you go from lemma 1, 2, 3, 4, they are getting more complicated than the hypothesis, and then lemma 5 simplifies. Lemma 6 gets more complicated again, and then the theorem is simpler. Okay, and that's what makes this a challenging problem. Now while I stated that, this has rushed through 3 proofs of it, steps of it, so I'll scroll. The first step gave us the first 4 goals. This involved instantiation and function application, that is computing f of x, and also given an equality a equals b, deducing f of a equals f of b for a function f which is also generated by the system. So the first step, which happened instantly almost, gave you the first 4 goals. The second step took a while. This involves equalities, processing equalities by symmetry and transitivity. It generated the 5th lemma, and the key point is it noticed the statement was simple and gave it a degree of 1. Okay, and so well, now it has finished running it, but we will anyway look through the next 2 stages. The next stage was again like the first stage, that is, you're using function applications and you're generating by applying a function to both sides of an equality. This got us up to the 6th step, and finally equality, transitivity and symmetry got us the theorem, at the end of which it states the theorem and gives you a full proof within Lean's foundation. Again, the statement being simple has meant that this has degree 1. So it showed that we identified simple statements at least correctly and used them. Okay, this was a quick demo of the first problem. This was the forward reasoning. This is the main one. The second one is much quicker actually, and so I'll state the statement before running it. It says if I have a function so that f of n plus 1 is f of n for all n, it's a function on natural numbers, then the result is constant. If you run it, it will tell you the statement. This uses some mixed reasoning, and as you see, it did it in 3.5 seconds. The previous one was a little more intensive. It took 1.5 minutes. This one you could even run in the interpreter, but there it will take a few minutes. Over time, of course, the hope is there'll be better and quicker ways to run these things, so you could work with the greater power interactively. As I mentioned, this screencast is to accompany the code and also a blog that explains the code. So if you directly came upon this screencast, then you should look at the description in YouTube, and that will have links to both a blog post as well as the code explaining what you just saw.